Hello and welcome, and in this particular episode, you're going to be looking at inheritance. So, inheritance is a mechanism for creating a new class that specializes or modifies the behavior of an existing class. And the original class, in that case, we would call it a superclass, and the new class that derives from another class is going to be called the subclass. Then, with inheritance, a class that is created by inheritance tends to basically inherit all the attributes and functions that are defined in the superclass. So for the most part, inheritance, we're actually going to be using it in order to build even more specialized instances of an existing class. Maybe an example that we can actually use from the real world is maybe, let's say we have let's say a production line, right, that typically manufactures a certain type of beverage, and we can use the same production line to produce different kinds of beverages. Maybe take, for instance, if you were to say visit the Coca-Cola plant, right, you'd realize, or maybe a Delta Beverages plant, you'd realize that they use the same production line to create, or rather to manufacture beverages of different types. So you can have, or rather flavors. So you can have your Coca-Cola, you can have your Fanta, but they are all basically coming from the same production line. So what's only going to change is that they are just going to make slight modifications to the production process. Or maybe another example that we can actually use is that of maybe, let's take for instance a ball, right? If I were just to say think of a ball, you would think of a spherical object, right? And depending on the kind of person, or rather the kind of sport that you would prefer as a person, you might imagine a soccer ball, or you might imagine a basketball, you might even imagine a tennis ball, is it? So I want you to notice how all these different kinds of balls, they basically inherit, or rather they have the same properties. They are all spheres, and they might actually share some properties like bounciness and so forth and so on. So you can actually take the whole concept of a sphere and then modify it to suit a particular purpose. Like, for instance, from a sphere, we can create a basketball. From a sphere, we can create a soccer ball. From a sphere, we can actually create what? A tennis ball. So that's basically the whole idea of of inheritance. We have a base class, and from that base class, we can actually create what? Subclasses. So in order for us to actually get started in this particular tutorial, let's create a class called rectangle, and within the rectangle class, we're actually going to let me just leave it like that, rectangle. Then let's have the init method, the constructor, as it were. So let's have init, right. So remember, the first parameter that you always have to pass, or the first argument within any method that you define inside of a class, is the init method. So in this particular case, we are going to have init self first. Then we know that a rectangle is going to have two sides, so we can say side 1, or rather maybe let's actually use the proper terms. So we have the length, if I could just spell length, right, and we have the width, is it? So when you create our particular rectangle, we actually want to have to make it so that it has a length and a width. So you can then proceed to set the length of that particular rectangle to whatever length has been passed during object creation. Then we can also go ahead to set the width of our particular rectangle to whatever width is going to be passed upon object creation. Then we are done with our constructor. Then we can move on to create some other functions that we'll be using for our rectangle object. So maybe, for instance, we would want to calculate the area for our particular rectangle. So let's go ahead and define the area method. So we just want to have self in there. Then we also want to have another variable called area. But before we do that, let's actually say rather, let's just do this. Let's say area is equal to self. So we know that the length, that the area of a rectangle is given by the length multiplied by the width, is it? So we can just say self.length multiplied by self.width. So that's our area. Then we just want this method, rather this function, to return the area whenever we call it. So it's just going to give us the calculated area for a particular rectangle. Then we can actually go ahead and create another method, another function rather, called self, called perimeter. I'm passing self as an argument. Then within there, we actually just want to calculate the perimeter for our particular rectangle. So we know that the perimeter is actually going to be equal to 2 multiplied by the what? By the length plus the width, right? Actually, it's supposed to be self.width and self.length, right? Then we just want to return the what? The perimeter right there. So basically, this is our rectangle class. It is the default method, which is init, or the constructor, which we will use to instantiate rectangle objects. And we have two additional methods or functions, right? We have the area and the perimeter, which calculate basically the area and the perimeter for our given rectangle. So let me actually create a variable called, rather, let me just call it rect1. I was about to call it first rect, but let me just call it rect1. So rect1 is actually of type what? Of type rectangle, and maybe let's say it is a 50 by 12 rectangle, right? And let's go ahead and just print the area for this particular rectangle. So we can say the area of rect1 is, then we just concatenate with the area. So in order for us to actually calculate the area, we have to call the object, then use the dot selector to what? To actually call the area method. So here we want to call area instead of perimeter. So area just like that. Then maybe while we edit, we might actually just go ahead and print the perimeter as well. So we can just say perimeter, then just change up right here the perimeter of rect1 is. So let's just go ahead and run this script, and you realize that the area of the rectangle is 600 and the perimeter of the rectangle is what? Is 124. So this is the base class that we have, right? And what we want to do is we want to demonstrate the concept of inheritance, and in order for us to actually do that, we want to create another kind of shape, or rather another class called square, because a square is just a special case of a rectangle. It's just another four-sided shape, but it's just a rectangle that is both sides equal, the four sides equal, as it were. So let's just call let's just create that the square class. Then if you are going to create a class, or rather a subclass, that's going to inherit from a superclass in Python, the way you are going to do it is to actually have parentheses after the class name. Then inside of the parentheses, you are actually going to have the name of the superclass. So we want our square to inherit from the rectangle class, and this is the way you show inheritance in Python, right? You have the name of the subclass and the name of the superclass in brackets, just like that. Then inside of here, what you can actually do is maybe just to show that inheritance is actually working in this particular case, I'm just going to use the pass keyword, is it? So this is basically just an empty class, right? But this square class is actually inheriting from the what? From the rectangle class. And in order for me to actually demonstrate this concept, let me go ahead and create a square. Let me call it square1, and let me just equate it to let me just call the square method. Then I will have to pass in two values, that is the length and the width for my square. So you know that a square is both sides equal, so we can just pass 25 and 25. That is the long and the short edge, they are basically equal, so we pass 25 and 25, just like that. Then I'm just going to go ahead and print the area of let's call it square1, just as we did in for the variable name. Then square1 is Then we call the square method. Use the dot selector to actually access the area method, right, or the area function is it way. So I'm just going to go ahead run this script in the terminal. So we have so you realize that it says the area of square 1 is what, 625. Now you might have noticed something interesting right here. If you come back to look at the square class, you realize that we do not have any methods inside of the square class. Right, we do not have anything in here. So it means that if we create a square class, technically, since we do not have anything in here, we shouldn't have this area method available to us ordinarily, right? But if since we are using inheritance, let me actually just go ahead and do that. Try to do that right here. Remove the inheritance right there, and I'm actually going to try and run the script. So you realize that it says that square takes no arguments, right? So in essence, since we did not define a method for inside of the square class, right, it wouldn't work ordinarily, right? But the reason why it worked the first time around is because we are using inheritance, and the square class is actually inheriting anything that comes from that is within the rectangle class. So if you remember, when you read the definition right here, is that we said the new class, or the subclass, right, it inherits the attributes and functions that have been defined in the base classes. So since the square class is actually inheriting or basically it's extending the rectangle classes, it actually now means that this constructor again is also going to apply to the square class. This area function is actually going to apply to the square class, and this perimeter method is actually going to apply as well to what, to the square class, such that even if I wanted to find the area for this particular square, I could actually rather the perimeter for this particular square, I can actually do that. So just go ahead and run that script. Maybe let me just clear the console first, then run the script. So you realize that the area of the there's not supposed to be areas now, since we are calculating the perimeter right here. So let me just change that to perimeter. So clear the screen, then run the script one more time. So you realize that it says the perimeter of square 1 is what, is 100, right? So that's the whole concept of inheritance, right? It allows us to reuse existing pieces of code by that existing in one class, right? So we have a class that already exists, but we realize that we might actually want to do some additional stuff with that particular class, or to have sort of like a specialized function. So we can actually do that using inheritance. What we could actually do is with inheritance, you can actually override methods or functions that already exist in the superclass. So for instance, in this particular case, we can actually change the area method, right? Or we can even add additional methods right here. So maybe let me say, what other functionality can we do? Maybe let me just remove this pass method right here and just define a method called display name. So it's supposed to be display name, right? Then what I can do is I can have an additional attribute inside of this class. So I can set name to shape name to an empty string initially. Then inside of the display name method, what I can actually do is this. I can then come here and say what do I want to do? I want to set the name, so I can say self dot name rather dot shape name is equal to maybe I should supposed to have another parameter right here. Should I pass the name right here? So I can just say you know what, let me just leave it. I think I'm just gonna leave it. Let me just put back the pass keyword right there. Maybe I'll just demonstrate this concept later on when we start looking at other concepts, like when we get to file handling perhaps, or even to scope. I think maybe when you get to scope, you can actually just go about that. But I think, yeah, that's just about it for inheritance. So basically, inheritance, just to sum it up, inheritance allows us to what to extend code that exists in an existing class, right? When you create a new class, and you can actually add additional functionality to the super class, as it were. So that's just about it for this episode. I'll see you in the next one.